Did the future already happen? The paradox of time. A question that challenges reality. Imagine for a moment that you're reading this article while simultaneously being born in a hospital and taking your last breath on your deathbed. Sounds impossible, right? Yet, according to some of our most advanced theories of physics, this seemingly absurd scenario might not be as far-fetched as it appears. Welcome to one of the most profound paradoxes in modern science, the nature of time itself. The intuitive view: time as a rolling film. Most of us think about time the way we experience it, as a continuous flow from past to future, with only the present moment being real. It's like watching a movie. Each frame represents a moment in time, replacing the previous one as we move forward. The past is gone, preserved only in our memories, while the future remains unwritten, waiting to unfold. This intuitive understanding of time aligns perfectly with our daily experiences. We remember yesterday, live in today, and plan for tomorrow. We make choices, face consequences, and believe we're authoring our own stories as we go along. It's a comfortable perspective that has served humanity well for millennia. Einstein's bombshell: relativity and the block universe. But in 1905, Albert Einstein dropped a theoretical bombshell that would forever change our understanding of time. His special theory of relativity, later expanded into general relativity, revealed something extraordinary. Time isn't absolute. Instead, it's intimately connected with space in a four-dimensional fabric called space-time. The death of simultaneous now. One of the most shocking implications of Einstein's theory is that there's no universal now. Two events that appear simultaneous to one observer might occur at different times for another observer moving at a different velocity. This isn't just a matter of perception. It's a fundamental feature of our universe. Let's explore this with a thought experiment. Imagine three advanced civilizations in distant galaxies, each with instantaneous communication technology. Yes, this violates physics, but it helps illustrate the point. The first civilization is stationary relative to Earth. The second is moving away from us at high speed, while the third is approaching us at the same speed. According to relativity, each civilization would experience a different now. When the stationary civilization communicates with Earth, they might share our present moment. However, the civilization moving away from us might find themselves talking to our past, perhaps conversing with people from 1924. Meanwhile, the approaching civilization could be communicating with our descendants in 2124. The block universe theory. This relativistic view of time leads us to a profound possibility: the block universe theory. Instead of time flowing like a river, imagine the universe as a four-dimensional block where all moments, past, present, and future, exist simultaneously. In this view, time doesn't pass in the way we think it does. Instead, all moments are equally real, existing together in a vast cosmic structure. The quantum wrinkle: uncertainty meets determinism. Just when the block universe theory seems to solve our temporal paradoxes, quantum mechanics throws a wrench into the works. At the quantum level, nature appears fundamentally probabilistic rather than deterministic. The problem of quantum randomness. Consider a single radioactive atom. According to quantum mechanics, it's impossible to predict exactly when this atom will decay, not because of our limited knowledge or measuring capabilities, but because the timing is inherently random. This quantum uncertainty seems to conflict with the block universe's implication that the future is already written. Butterfly effects and quantum cascades. This quantum randomness isn't just a microscopic curiosity. Through what scientists call amplification, quantum events can have macroscopic consequences. A single quantum decay might trigger a mutation in a living organism, leading to evolutionary changes that affect entire species. If the future already exists, how can it accommodate these genuinely random events? The growing block universe, a possible resolution. One potential solution to this paradox is the growing block universe theory. Instead of a static four-dimensional block, imagine the universe as a growing structure. The past exists as a solid block, while the present forms an uneven surface where quantum possibilities collapse into reality. The present as a quantum interface. In this view, the present moment isn't a simple slice through space-time, but a complex, rippling surface where quantum potentialities become actualities. This surface grows moment by moment, adding to the block of the past while maintaining the openness of the future. Free will and determinism reconciled? The growing block universe offers a potential reconciliation between our experience of free will and the relativistic nature of time. While the past is fixed and determinate, the future remains open to possibility, shaped by both quantum randomness and our conscious decisions. Time's deep mysteries, beyond current understanding. Despite these sophisticated theories, the true nature of time remains one of science's deepest mysteries. Some physicists suggest that time might be emergent, arising from more fundamental properties of the universe, just as temperature emerges from the collective behavior of molecules. The thermodynamic arrow. One clue to time's nature might lie in thermodynamics. The tendency of isolated systems to increase in entropy provides a direction to time, the famous arrow of time. But why does entropy increase in one direction only? And what does this tell us about time's fundamental nature? Time as an emergent phenomenon. Recent theoretical work suggests that time might not be a fundamental feature of reality, but rather an emergent property, something that arises from deeper physical principles. Just as wetness emerges from the collective behavior of water molecules, time might emerge from more basic aspects of the universe. Philosophical implications. Living in a timeless universe. The nature of time raises profound philosophical questions about existence, consciousness, and free will. If all moments exist simultaneously in some sense, what does that mean for our sense of self and our ability to make choices? The illusion of now. Our experience of the present moment might be more complex than we imagine. Some philosophers argue that consciousness itself creates our sensation of time's flow, while the underlying reality might be timeless. Memory and identity. If all moments exist equally in a block universe, what makes our memories of the past different from our anticipations of the future? How does our sense of personal identity persist through time? Practical implications. Living with time's paradoxes. Understanding time's paradoxical nature might seem purely academic, but it has practical implications for how we think about our lives and choices. Decision-making in an uncertain universe. Whether the future is determined or open, we still must make decisions based on our best understanding of cause and effect. The quantum nature of reality suggests that while we can't predict everything with certainty, we can make probabilistic assessments, the value of now. Even if the present moment isn't fundamentally different from past or future moments, our experience of now remains crucial for consciousness and decision-making. It's the interface where we can affect change, regardless of the underlying nature of time. Scientific frontiers, ongoing research. Modern physics continues to probe the nature of time through various approaches. Quantum gravity. Attempts to reconcile quantum mechanics with general relativity might require fundamentally new ways of thinking about time. Some theories suggest that at the smallest scales, time might be discrete rather than continuous. Consciousness and time. Neuroscience research explores how our brains construct our experience of time, potentially offering insights into the relationship between consciousness and temporal experience. Embracing the mystery. The paradox of time remains one of science's most intriguing puzzles. Whether we live in a block universe, a growing block, or something even stranger, the nature of time challenges our assumptions about reality itself. While we might never fully resolve these temporal paradoxes, exploring them enriches our understanding of the universe and our place within it. Perhaps the greatest lesson is learning to hold multiple perspectives simultaneously, embracing both our lived experience of time's flow and the possibility that this experience might be just one facet of a deeper reality. As we continue to probe these mysteries, we're reminded that science's greatest gift isn't always definitive answers, but rather increasingly sophisticated ways of asking questions about the nature of existence itself. Looking forward, or is it backward? As we conclude this exploration of time's paradoxes, we might wonder, are we actually concluding anything? Or have all possible conclusions already existed? Perhaps the best approach is to embrace both possibilities, to live as if our choices matter while remaining humble before the profound mysteries of temporal existence. After all, in a universe where past, present, and future might all exist simultaneously, The journey of discovery itself might be more important than any final destination. And that journey continues through time, whatever it might truly be.